I'm actually very excited to talk about the Hubble Space Telescope. It's so cool.
Well, do you mind telling any of our listeners what the Hubble Space Telescope is, if they were to have somehow not heard of it?
Yeah, well, a big part of science education is naming things in a way that's self-explanatory, and they've done a really good job with the HST, because the Hubble Space Telescope is a space telescope. It is named after the astronomer Edwin Hubble, and it's run by NASA in a low orbit to evade the disruptions to accuracy caused by the Earth's atmosphere when you try to take measurements and images and collect data on the farthest edges of the observable universe. And it's one of, I think it's one of the greatest contributions to astronomy so far in the history of science, and it's just so cool. I love it.
I absolutely agree. I mean, I'm no astronomer, but from what I've read about it and from what I'd seen about it before, I do think that its contributions to astronomy are very significant. I mean, you could measure that just in terms of citations. There are over 15,000 papers based upon data collected by the Hubble Space Telescope, published in peer-reviewed journals. But aside from the citations, I think the way in which it generates photos that are so visually fascinating to a layman is what makes it probably fair to say it's by far the most famous of the 4 great observatories. I don't know if you read about the 4 great observatories.
Yes, to cover to different telescopes and other equipment to cover different wavelengths of light, right?
Yeah.
So the Hubble mostly operates in the visible and infrared spectra, I want to say. I think that's correct. Which obviously is only a slice.
Hubble is visible and near ultraviolet light.
Other way, yeah. So it's really the kind of front, the celebrity of the great observatories, because it covers the visible section, right? Like,
yeah.
It's more. Almost more authentic to see images from Hubble, because even though they've been kind of processed and spliced together, the actual light in theory is something that we would see and recognize, whereas if you're doing, say, photography in wavelengths of gamma radiation instead, you have to kind of interpret it in processing so that it becomes something that's visible to a human, so that you can understand what they're looking at. So Hubble's the big, most famous one, and I think I agree with your point on just kind of the photography of it as well. I think everyone will recognize some of the most famous images that have come from the HST, even if they're not aware that it's Hubble that's taken them. My personal favorite, although it's not one of the really niche ones, it's just the famous image called the Pillars of Creation in the Eagle Nebula, where you have these enormous kind of gaseous formations lit up with kind of red-orange stars in the background, and it's
magnificent, isn't it?
Yeah, it's beautiful. And I'll just plug as well. Hubble has its own website as part of NASA, hubblesite.org, and they have an entire database of some of their best images and artistic interpretations and graphic infographics and things, kind of over 4,000 of them. So if you ever want to experience anything from scientific artwork to minor existential crises, hubblesite.org has you covered.
Definitely something to check out. I definitely think that it runs a risk of being almost sneered at maybe by some saltier members of the scientific community, because of course there are 3 other telescopes that would be considered among the 4 great observatories, as we've mentioned, but it's much harder maybe to appreciate for us not being deeply involved in the field, the significance or to gain any fascination in the images that come out of these other telescopes. I mean, maybe they do look good. I've just never seen them, so I imagine they don't gain quite as much traction. But I would say, regardless of contributions to science, being able to engage with the general public in the way that Hubble has been able to do, I don't think it would be unfair to say it's been a massive boon to astronomy in general, because if you can create a public interest in this field, then that's really good for engaging the public as stakeholders to invest in the field, to invest in NASA, and to get more of this research done, even some of this research that doesn't produce photos that we'd necessarily know and love.
I agree, and I actually think there was a section of the article where it was almost assessing the success of Hubble by comparing kind of its academic literature output versus in terms of citations versus other observatories' citation literature outputs, and then comparing those figures to the overall cost of running and maintaining each observation platform, be it ground-based or space-based like Hubble. And it almost framed it as a bit of an ongoing debate, because well, not perhaps less so now, but certainly when it was being developed, Hubble had a bit of a rocky start before it got off the ground. So because it's such a complicated device platform, with so many considerations, from the optical engineering side to the rocketry side to the kind of scientific analysis equipment that needs to be on board, to looking after and anticipating its decay rate and its system failures, having backups. How do you stabilize it? If something goes wrong, how do you fix it? And because of all of these different considerations, lots of different contractors were assigned or commissioned for different components of the overall telescope. So, for example, Lockheed Martin was the company behind the actual spacecraft itself, but the optics and the optical systems were instead manufactured by Perkin-Elmer, and NASA coordinated everything, and so on and so forth. And all that said, it's perhaps unsurprising that it ended up being kind of quite over budget and way more expensive than initially anticipated, and there were delays after delays, And then, of course, less than a year before it was initially it was set for its final launch date. It's okay, we've delayed it this much, but now we're definitely going ahead. There was the Challenger disaster, tragedy, where the Challenger space shuttle, I think it was a space shuttle as opposed to a rocket, exploded when it about a couple of minutes after takeoff, live on television as well, I think. And it grounded all space shuttle launches and rocket launches from NASA for months, years. And so Hubble had to be shelved, but of course it's not designed to be kept in atmospheric conditions for very long, so they had to then construct special storage equipment and spaces for it, and it could be maintained and all of this. So despite the incredible and undeniable contributions to astronomy, it's also an extremely expensive project. I think NASA's most expensive project ever when you adjust for inflation. But to be clear, I'm not kind of going on this spiel and saying that's a bad thing. I think it's really admirable that so much has been invested into just an area of science that's consistently outputting incredible advances in our understanding of how the universe works. I think it's amazing. If you're going to spend billions and billions of dollars on a project, I think something like a space telescope is really high on the list of candidates.
Yes, it's quite amazing, isn't it? Speaking of the difficulties faced by Hubble, it was launched with a faulty mirror, wasn't it? It's got a massive 2.4 meter, or in imperial units, 7'10" mirror for capturing those great photos in low light conditions. And something was wrong with it when they launched it, which was in 1990 they launched Hubble. And it wasn't until 1993 that they managed to service it and correct the optics to their intended quality. So I think they still could get some images with it, but it was not as intended at the point of launch until 3 years after.
Yeah, that's right. There's an entire section on this flawed mirror, and it would be when I was reading it, I was thinking, this is a classic case of a classic example, go-to example of how a very, very tiny thing in an extremely complex assembly system can cause not catastrophic, not fatal, because it was ultimately corrected okay, but pretty disastrous error rates and completely unexpected as well. So they had made the precision of the mirror was correct, but one of the lenses was out of position by 1.3 millimeters, and that was it. But it was enough to throw the testing. I want to get this correct. When they were observing the running tests on the mirror to make sure that it was correct, they had developed kind of a custom-built piece of equipment to ensure accuracy and precision, and because it would kind of been developed in sync with the manufacturing equipment, it was they missed the error. The normal measuring tests and equipment actually caught the error, but the results were dismissed because they were the regular testing equipment was considered worse than this special custom built. We built it for Hubble to measure exactly this device that whatever device you use to test mirrors. I'm not an expert on mirrors. And so although they caught the error, or the error was recorded, it was dismissed. But ultimately, they should not have dismissed it, because this 1.3 millimeter error led to the arc second, estimated or anticipated arc second diameters of their resolution to be out by like an order of magnitude. It says that some of the images were coming up with over 1 arc second diameters, and they were meant to be 0.1 arc seconds. So that's just enormous. And there's actually an image in the flawed mirror section of the article that demonstrates this quite well, where you see a star, and it's meant to be a nice concentrated few pixels, and instead it's just spread out like light through a dusty window.
Yeah, I'm seeing that. Not quite precise.
Yeah.
Have you seen? Sorry to change the subject, but have you got your proposal ready? Anyone can apply for time on the telescope.
Yeah.
Could be you.
Yeah. What do you think about this idea of allowing kind of anyone, like just literally anyone, to use NASA's most expensive piece of equipment in real terms? I think it's great. I know in practice, although the Hubble was originally did have some time set aside for use by amateur astrologers, there were only a few individuals who were able to secure it, and after the costs increased unexpectedly, as these things always do, unfortunately, in practice, amateur astronomers are no longer able to use Hubble. But anyone can apply to use it in a more kind of academic and regulated sense. The Wild West days of Hubble are long gone.
Yeah, I think it's really good that they are actually open to receiving requests from more than just, say, their affiliated universities. I mean, it's not exactly democratic, but what it allows them to do is to take input and ideas from any collection or individual budding astronomer from any part of the world who has a good idea, and to run with it. So it's just it's something that reduces a limitation on what the telescope can be used for, because it can sometimes be difficult when you've got such limited resources to know in science actually what questions to ask, not just what are the answers to them, but what questions can you ask. And if you have more people providing more alternative good questions, and then the people in charge of the telescope can have a look at them, decide, actually, this is better than the idea that we had earlier, so we'll run with this one. So it's quite competitive. I mean, even if you got together a proposal that was fairly sound, I think it's about 80% will not have the opportunity to use the telescope. But if your idea is really good, you have a shot.
Clearly the solution is to build more space telescopes.
Luckily for you, that's been done. We've got James Webb.
And his telescope that he personally constructed just for us.
Yes.
It kind of feels almost rude to talk about the James Webb Telescope in the Hubble podcast, because it's just
it does.
better.
It needs a moment, though. It needs a moment. It's worth mentioning to any listeners who are unaware. The James Webb Space Telescope is a new telescope launched in 2021. Obviously, also a space telescope. You could say that Hubble is its ancestor, and it is the new generation of space telescope. I mean, I knew many people who were very excited about it. This one, named after James Webb, obviously, not named after Edwin Hubble. James Webb was a NASA administrator who led a few significant programs, including the Apollo programs. Yeah, so I expect we're going to see some great things from James Webb over the coming years.
I'm really excited to see what comes out. I'm quite basic with astronomy. I love reading about all of the discoveries, and I love conceptually the idea of humanity pushing the final frontier further and further. But I'm not trained in kind of formal astronomy, well, not even formal physics. We'll start with that. To a particularly advanced degree, you're ahead of me on that. So I don't understand the nuts and bolts of how things work.
Well, for any listeners, he's saying I'm ahead, but I only took A-level physics for 2 weeks, so we've not really got much expertise here.
You do have 2 weeks on me, though. That's like 4 whole hours of time. Which is about how long it takes to read the article, actually. But there is a really nice NASA infographic of the evolution of kind of observation platforms, and how they, as time has marched ever onwards, the new equipment is able to resolve images farther and farther away, which, due to the expansion of the universe, in practice means we get to see more and more into the past as the redshift Z value gets larger and larger. We can resolve images closer and closer to the Big Bang, and 1990 ground-based observatories, according to this infographic, could resolve things roughly with a redshift Z value of 1, which would be about 6 billion years ago. The farthest light that can be resolved hitting the observation platforms. And then when Hubble was first launched in the 90s with Hubble Deep Field, that pushed it up to 1.5. A Z value of 4. And I've realised as I'm speaking, I've actually been reading this backwards. The infographic, now that we're going to have to put the infographic up, because it has a timescale, but the present day is on the left, and then the Big Bang is on the right. But it's not years ago. So I'm going to stop talking about it now. But yes,
I have to remember to put that in there.
Yeah. Just look at it.
Well,
look at it. It's beautiful.
The age and expansion of the universe is quite relevant to the Hubble telescope, not least because it's named after Edwin Hubble, who was around 1889 to 1953. But what he is known for, he's linked with some jargon here. He helped to establish the fields of extragalactic astronomy. Do you remember what that one means? Just astronomy of stuff outside the Milky Way, I suppose. And observational cosmology. Now that is more to do with... That is more related to the expansion of the universe, I think. I don't recall exactly what it means.
Well, of course, one of the most significant contributions that Hubble has made to our understanding of the universe is a kind of this discovery that, contrary to what was previously believed, that the universe expands and expands and expands and then shrinks and collapses again under its own gravity, the expansion of the universe is actually accelerating. And we don't know why. Which is where, so it kind of, the Hubble is kind of responsible for at least partially responsible for the kind of the discovery of this idea of dark energy, which sounds like something out of a Hollywood sci-fi film. But dark in physics is code for we can't observe it, we can't see it. We know that it exists because we can prove that the expansion of the universe is accelerating, but we don't know why, so we're going to say that there's this currently unobservable phenomenon thing called dark energy that is responsible for it. And it kind of sends...
It's truly the villain of the sci-fi.
It's kind of like, yeah, kind of sends shivers down your spine to think about, like, but it's kind of exciting.
There are
as
dark
well.
forces out in the corners of space.
Yeah, but it's
You can't see them.
It's sort of like, but what is it? We don't know. It's
To be honest, if we could observe it, I probably still wouldn't know what it is.
Well, that's true. That's true. Only a few very intelligent PhD Nobel Prize winners will ever truly understand dark energy. But I will always have a very small amount of resentment for the person who clarifies what it is, and it will probably be renamed to something a lot less cool sounding. As this is the paradox of coolness in science. The more you understand it, the more boring it becomes. As you inevitably are forced to confront more and more fine detail, and there's an ever increasing number of asterisks attached to the end of any statement you can make. Whereas when you don't know anything at all about it, although to be fair, there is actually quite a large Wikipedia article on dark energy, but it begins by saying, in physical cosmology and astronomy, dark energy is an unknown form of energy that affects the universe on the largest scales. Full stop. Which is like the most blanket generic statement possible. Like, if someone says, what is something, and you say it's an unknown form of energy that does stuff, like, we can't say much more than that.
Yeah.
Which is just
I mean, to many people, including myself probably, even just the term energy can be quite elusive.
Did you ever do that thing as a child where you ask your parents or someone, like, and you go, yes, but why? And you just keep asking yes, but why, until they lose patience with you, but you try and see how far down the rabbit hole you can go.
I don't have many memories from being very young, but I do think that must have been me. I thought about a lot of strange things in a lot of depth. I mean, I think any of us with interest in even minor and fleeting interest in religion, philosophy, and politics tend to spend a lot of time thinking about things, even if we don't know very much about them.
You think, therefore you are, to paraphrase a famous philosopher.
Abraham Lincoln.
So we're kind of bouncing all over the place, which is really exciting because there's so much to cover here. When you were reading this article, what did you find more engaging? Kind of the nuts and bolts details of the telescope itself, and the history around it and its relationship to NASA and the manufacturers, and the Challenger disaster and then the Columbia disaster 18 years later, or the kind, or more the astronomy proper side of things, where once it's up there, now let's have a look at the universe, let's have a look at the stars, from a kind of meta perspective regarding the article itself. What did you find most engaging?
Well, it's certainly interesting to hear about failure and overcoming failure in terms of the engineering side of things. I guess I'm usually most interested in stories when they revolve in some way more around the people involved, and just imagining people having to deal with these problems once they've reared their heads. It's quite a compelling story. I don't know. I've not gone into a great deal of detail on the true astronomy side of what has been discovered. I'm a bit more of a normie. What I find really engaging about it is the way it reminded me of the great excitement and inspiration that something like this can bring to the world. Like meeting a load of very excited young wannabe scientists talking about something like the launch of James Webb, or seeing groundbreaking images like of the images of the black holes that we've had released in the past couple of years. Just it's the sense of collective excitement that really resounds with me, and this article just reminded me of that feeling.
For me, the article on the Hubble Space Telescope is one of those ones where you can just tell that it's at least partially been written by people who were very, very close to the actual construction of Hubble. There's such a big overlap between kind of Wikipedians who write these articles and workers in the scientific community, right? It's really, really obvious, and I love it. I love the feeling of like, oh, one of the engineers has probably written this paragraph, because especially when you get into the engineering side of the HST, it goes into excruciating detail. Like the density of detail goes way up, but tellingly, the number of citations goes way down, which suggests that the person who wrote it knows exactly what they're talking about. Either that, or they're obviously, it's Wikipedia. They could just be making it all up. But
let's say a conspiracy.
But I'm not sure what the purpose of it would be. I was actually struck by, there's a photo that we'll probably show around now in the construction and engineering subsection, where there's a gentleman overseeing the grinding of Hubble's primary mirror, taken, according to the uploader, March 1979. And you can see, firstly, the size of the mirror. It's just enormous. And it's clearly some sort of clean room. Like there are things in kind of plastic wrapping, and it's the center of focus, and there's just this huge grinder machine that's working away. But there's also just a person with 70s haircut and a huge tie and a white shirt, who's just fully leaning on the mirror. It looks like, it might just be the angle of the photo, you can only kind of see his top half, but it looks like he's just leaning on the mirror, and he's not wearing like a protective suit or any PPE or anything like that, and it just evokes a bit of nostalgia in me, because I feel like today, if a very important telescope with a one-of-a-kind mirror were being assembled, you wouldn't be allowed within 10 meters of it without wearing a clean suit at any stage.
Yeah.
And that's almost certainly for the best. But I just love this photo for that reason. It's just a bit of a blast from the past of just a guy who looks like an office worker leaning on the Hubble's primary mirror. I find it very entertaining.
I don't know what else to say, really. Or do you have a question?
Well, I mean, I not so much a question as just a series of things that I thought were awesome about reading about Hubble. Because prior to the article, I didn't, I knew obviously that Hubble existed, and I knew what it was, and I knew what it did, but I didn't know anything about the history or the technical details. And something that I hadn't really considered is how old it actually is. Like it's getting on a bit, right? Launched in the 90s.
Yep.
Was
older than me.
Was only expected to last, I think, 15 years initially, but then after 14 years, they realized there was almost no measurable decay to the actual mirror itself. And they were like, oh well, we'll just keep going then. And they kept updating it and replacing its systems, and I think now it's expected to last until kind of somewhere in the 2030s. So it's probably got another 10 years or so of its life still. And I bring this up because I was thinking in relation to the electronic systems on Hubble. Because to an extent, like, a mirror's a mirror, right? Like, you can make mirrors that are bigger and you can manufacture them with better technology and more advanced equipment to more and more fine detail. But at the end of the day, a mirror is a mirror. But the electronic equipment has come so far that I would love to know more about how a project this big that started by recording its data on like physical kind of film, almost film reels, is now still operating and making enormous contributions in the age of the cloud and much more kind of everything's gone digital, and it's clear how ignorant I am of how this actually works. But as an amateur, as someone who doesn't know anything about this, that's what I'd be really interested to find more out.
You could be imagining that we've got this satellite up there, churning away, recording onto like a VHS, and then we're taking that VHS, turning it into a CD, and then turning it into an MP4, and then reformatting it into a PNG so we can share it online. I mean, I have no idea how it works, but I see your point. Certainly, I mean, don't we hear that the craft that landed on the moon had about the same computing power or less than a modern handheld calculator? So these things do change.
Yeah. Maybe that's exactly what happens. Maybe it begins the data from the HST begins its life as being encoded as something from 20 years ago, and then just it's passed through several stages and cleaned up until eventually it makes its way onto hubblesite.org.
There definitely must be some post-processing that goes on. I mean, that was formed part of the debate into funding Hubble versus funding ground-based telescopes, being that there are techniques that we have now with processing ground-based telescope data, such that they are really, really quite good. Not as flawed as they used to be. Where obviously the benefit of having a telescope in space is that we don't have the Earth's atmosphere in the way. But even so, these space telescopes can image things that produce, or that we are receiving less light from. So we're still currently limited with what we can do with telescopes on the ground. Although we can make the mirrors on telescopes on the ground pretty colossal.
So we have about 5-ish minutes left. So my question as we come towards the closing section for you is, what would you like to see? And I mean that literally, visible light capture. What would you like to see more of in the universe? If you had control of Hubble for a few hours, and all of its personnel and equipment and staff and everything, what would you use Hubble to observe? What do you want to see?
That is a lofty question indeed. Yes, given that I wouldn't really know if there are already images of these things, or whether it's significant to image. I mean, obviously some of the pictures of nebulae that we've got from Hubble are very beautiful, so I wouldn't mind some more of those. But then, I'm a bit of a dreamer. Maybe we could point the telescope towards some stuff that we figure could sustain life, and point in those parts of the universe. Not that I'm expecting to find anything in the visible spectrum from stars and planets so far away, but just because, seeing an image of a real place that could have life or have had life, intelligent life, it just plays on the imagination, and it's cool to think about. How about yourself?
Well, I started. Obviously, I thought about this question before I asked it. Right, I was anticipating this reversal. I started from the same place as you, which is I know nothing about how telescopes even work functionally. I know what they do, but I couldn't build one myself, and I wouldn't know where to begin. So I would probably go the other way. If I magically found myself in control of Hubble, I would just I would love to have a play around with it. I would just love to but I know it's designed to observe the farthest reaches of the universe, but what if I just pointed it at my house? Could I see myself through Hubble?
Yeah, what would that look like?
We're so used to looking away from Earth with telescopes. What if I used a telescope to look at Earth, from space?
What does it look like if you... might just be a bit of a blur. What happens if you use a pair of binoculars to observe a single-celled organism?
Well, this is it, right? I don't think it would work. I want someone I need to talk to someone about this. Could I look at my house with the Hubble Space Telescope? I feel like what would happen is I'd spin. I don't even know how. I'm not sure how the HST kind of aligns itself. I know it uses gyroscopes for stabilization, and kind of alignments for photography. But in terms of the physical object, how it rotates in vacuum, I'm not sure how that works. But if I could point it at the Earth, I'd be actually quite scared that something about the way light interacts with the Earth and the atmosphere before it gets reflected back would destroy the mirror or something, in a film where someone gives a person who's unqualified control of something important, and they come up with an incredibly accidental yet creative way to destroy it. Would probably be what I'd end up doing with it. So it's probably for the best that I don't have control of Hubble. I will leave it to the experts.